So this is Python for neuroimaging for beginners, the third session. And today I'm going to talk about pipelines. But before, again, we need example data. If you have example data, download it and copy it to your home directory. If you don't have access to the RGS server, just get any 4D Nifty data, that will be fine. If you don't have FSL installed in the server that you're working on or in the laptop, you can just substitute all the command line with copy and try just test it whether your pipeline works. Okay, I'll be going back and forth between shell and IPython, interpreter, and VI pretty quickly. I'll be using NeoVim. If you're comfortable with NeoVim, try following it in NeoVim. If you're comfortable with GNU Screen is perfectly fine. Okay. And just a reminder, this is for people who don't have an engineering background and have an interest in learning Python to apply in your imaging. Today, I'll be talking about pipelines, but before, we have to solve a problem to learn Python. So please do solve a problem, find a problem related to your work and try solve it and solve another problem. There's no need to memorize. If you get stuck, search the web, and you don't need to memorize, just go along. And then find another problem and do it again. Okay. Quick recap. Last time we worked with arrays. So we used a module called NumPy, and we were transposing them. We were adding them. We were multiplying 2, 3, 4. We could get the columns and rows that we wanted by something called slicing or indexing. And we could stack the arrays together. And we could even overwrite values within the array using the slicing. Okay, and we did the same with Nifty files by using a module called nibabel. And yeah, we did the same, transposing them, array calculations on Nifty arrays, and then slicing them, stacking them, and we were plotting them using Matplotlib library. Today is a pipeline. So what is a pipeline? Pipeline is a set of functions grouped together in an order. So you give an input to function 1, then it gives the output. And that output goes into function 2, and the function 2 gives a second output. There's a simple pipeline. Okay, we can simplify it further. We can simplify it further by saying the first function is adding 1, and second function is multiplying 2. So you give an input of 1, then it's adding 1, then output will be 2, then 2 goes into the second function, which is multiplying by 2, output 2 will be 4. Okay, so when input is 1, output 2 is 4. All right, for us, for people in neuroimaging, we can think of it as this. So first function can be a brain extraction using BAT. Second function can be eddy, current correction using FSL eddy. Okay, input can be raw data and output can be brain extracted data, and that goes into eddy, and output 2 can be brain extracted and eddy current corrected data. So that's the pipeline, simple, okay? But all the pipelines that already use or you already use are probably much complicated than this. This is an example of pipeline that I used to work with. It looks very confusing, but if you look at one part, has an input and has some function, and has the output. So is pipeline. It's just a bunch of functions grouped together in an order. All right, let's start making them in Python. Let's start simple with Python. Okay, let's open a terminal. It'd be nice if you can go to the example data directory that you copied into your home directory, or if you don't have them, it's fine. Just do IPython. Then it will take you into IPython. And let's create a function called add1. You can create a function by defining a function by def. And you will say add_1. That's the name of your function. And it will take an input. I want to call it A. You can call it whatever that you want to, and then colon. Bear in mind there's colon. And press typing enter, and there's an automated tab there for spaces. So that's how you define a function. So you give a definition and the name of the function, and you give full tabs, full spaces, and you write the function. what is that function? Okay, that function is a plus 1. Okay, and I would like to return this as output. Return. Do this and press enter one more time. And let's try running them. Add underscore 1, say 10. Gives you 11, 4, 3, 5, 100, 101. Okay, it's giving something back to me. I can assign the value to output by doing this. So what is output now? 3. All right, simple enough. What happens if I do this? S. Should give error because you can't add 1 to a string. Okay, so it's giving error when the data type is not matched. Okay, next function is multiplying by 2. Let's make another function called definition multiply underscore 2, open brackets. Okay, I want to call it A. You can call it whatever you want to. I want to do A times 2, and I would like to return this. All right. Multiply underscore 2. Let's run them. I want to do 15, 30, 40, 1, 2, 3, 4. Okay, it's giving me the outputs. All right, let's make a pipeline now. I can define input value as 3. Output, the first output is add 1 into input value. Okay, it's adding 1 to 3, and output 2, which is the final output, is multiply 2 underscore output, which is the output from the first function. All right, what is the output? Okay, 3 plus 1, 4, 4 times 2, 8. Okay, let's make a pipeline called this. The definition pipeline input is A, colon, automatic tap. Let's do output equals add 1. Input goes into the first function, and output 2, multiply 2. The output from the first function goes into input as a second function, output, like this. And you'd like to return the final output, which is output underscore 2. All right, let's test the same thing. Pipeline, open brackets, parentheses, 3, turning 8. Okay, it's doing what I'm expected. You just made a pipeline in Python. Very simple. It's okay. All right, and you can make that. You remember on the first session we saw the ways of making a script that could be ran on the command line using sys and stuff like that. You can now do that, right? You can make that. I'll just pause that. Okay. You may say, then why not make a single function out of it? So adding 1 and adding 2, multiplying 2 looks like pretty simple. Why don't you make it as a simple, like one function? You can always do that, but there's a reason for this in doing pipelines. So there are some times when you do function 1 to some data and only function 2 on some data. So for example, you sometimes have a raw DTI image when you have to apply BET and then eddy. But sometimes you have brain extracted data where you don't have to apply BET and eddy. Where you don't have to apply BET, you just need eddy. So it's better to keep your function simple, doing one single thing. Okay. Let's make a pipeline, actual pipeline. In a part of this, we'll be using FSL ROI and BET. Let's try making that. So for those who don't know what FSL ROI does, is that there are times when we want to extract a single or few volumes out of 4D image. Like in diffusion weighted image, there are B0 volumes that we want to extract it as a separate Nifty file. That's what we use in that cases. FSL ROI For the input, we give the location of 4D Nifty file and name of the output. We normally call them B0 maps or no diff file, no difference in weighting file. And tmean is the starting point of getting the volume. So tmean, I want to set it as a 0, is here, and t size as 1. Then from 0, get 1 volume. From 0, get 1 volume. Then FSL ROI will get this B0 volume saved as an output. And for those who don't know what BET is, BET takes an input of on-brain extracted image, the raw image, and outputs without the skull, images without the skull. Okay, there are a bunch of options, but we're not going to think about that today. Okay, let's create a pipeline, this time in VI as a script. So you can go back to terminal by using exit, or move back to the other terminal. I'll just exit it. And ls, I see the example data now. I want to open my script here, vi simple underscore function .py. You can name it whatever that you want to. But since I'm using NeoVim, I have to use something else. You can just do vi, I have to do mvr. Okay, just open the script. If you will probably see the same thing. Let's start scripting. So import, I'm going to import OS module to run Linux command, and I'm going to make a function. So define function called extract b0, and I want to take input value, input file, and I want to know where I should save the output image, output file, output underscore file. Okay, colon, and then press enter. Mind the gap there, so you need 4 spaces. And let's create a command before we run it. So command is FSL ROI. It was this, isn't it? So FSL ROI, and input goes in, but there's a space. So you have to add a space, close bracket, and plus, input will be there, input file will come here, and then you need another space here. So another space, and plus, output file comes here, and plus, you need another space, and then tmean was 0, and t size was 1 to select the first 3D volume out of the 4D volume. All right, you just made a command. So command here, you can run the command as os.poppen underscore open parenthesis command, close it, and read. You will run it. And then, well, you can set out like this and print out. It will not output anything on the screen, but I'm just getting the output. Well, let's not do this. You can just do this. All right, and save it by :w for those who don't remember how to save it. Okay, I just saved it. So you have a simple function now. So in there, input file. Oh, let's make another function as well. Definitions. I will make a function that brain extract. BAT. I want to call it BAT, and it should have input file, and it should have output file as well. Okay. Colon, enter, automatic tab, commands. This time BAT space plus input file, and there's another space, right? And plus output file. Okay. And os poppen command and read. Now, next is building the actual pipeline function, which I run them. So define pipeline. It will take input file, and output file, colon, automatic tab. First, I want to extract the B0. I want to run the function that I defined above there and give input file. And this is the first output, strings. So you give temp, you give nodef like this. Then it will put string nodef into here, which will be in the commands as an output file. Okay, next, I want to run that on the nodef file that was created. And I want to put that as output file, the final output file that I defined, that I give to the pipeline function. Let's define them. So input file equals DWI nifty, which is in the same directory where I created the simple function, is at the same directory. And output file as nodef underscore brain. Okay, and I want to run this pipeline, input file and output file. Okay. Oh, wait, let's give the full address for the nifty file, for the DWI file. For me, my DWI file is here. For you, it will be in RGS server. Your locations might be shorter for you. So let's write that. Copy all, paste here, change that to nodef. Okay. Do you see what I'm doing? So I'm building two functions, and I'm creating another function that merges the other two functions in order, and I'm running that here. I want to save that, :W. You can run in the NeoVim or whatever in someone else. I would just go out, :Q, WQ, save and exit. Or the ls, I see simple Python here. Let's do Python, simple Python. Doesn't say much yet because I didn't print anything in there. My terminal is locked, which means it's running something. Spec, let's do ls. I have the nodef file here. I don't know why. Oh, I marked the output wrong. So output file should be nodef underscore brain, okay? Because nodef file is there. Let me do it again. My bad. So mdr, simple function. So output file should be nodef brain. I don't want to overwrite the first output. Save to here. I just change nodef into nodef underscore brain. Save, exit. Example data, Python, simple function. Let me remove nodef. Python, nothing. Python, simple function. It's running, it's locked. Okay, it's done, ls. So you have intermediate output, which was nodef, and the final output, nodef.nir.gz. You just made Python pipeline running that, FSRRI, and then that, okay? And you can just add on the other functions. You can add on eddy, you can add correlation analysis to it, or you can just use NumPy to extract others. You can change other values. That's just as simple as it goes. That's the simplest pipeline that you can use. Okay. All right. Another Pythonic thing that I have to show you, when you make a script. So from the first lecture, we did sys, all right? sys.argv1 and 2, get the output. It's perfectly fine to have script like that we have now, which looks like this, but it is always better to have something like if name underscore twice, main underscore twice, main, and just put them under a tab. It's always better this way. to make a script, because there are times when you want to import extract B0 that pipeline into a different pipeline, and you don't want to run that every time. You just want to run them when the script is ran on the command line. It's just basically saying that. So if the script is ran in the command line, run these. If they are imported as a script in different Python or different scripts, just don't run these. Okay, if you don't get it, don't mind, but just remember there's something like that. Okay, now you just made a part of the pipeline. Okay, you can now say that you can build a pipeline using Python. Yeah, but there are quite many uncomfortable things in the script. You remember, I don't like this. It's very confusing to write something like this. So there's a better way of doing this. So let's go to IPython again. So in IPython, I'll have example here. So this is the way that we did. So greeting equals hello. And my name is Kevin. Oh, sorry. Greeting equal hello. Name Kevin. Visit underscore time is 3. To create a message, I have to do something like this. Message equals greeting plus space plus name plus another string, adding dot, and then you have visited another space and close it plus. Since it's the integer, we can't plus it. We have to change the types into string. Visit time plus another space times. And I make typo. Visit time is not created. I make a typo here, so I do it like this. It is so confusing to make it like this, okay? But it's much easier if you use something called formatting in Python like this. So you can create a message equals, put F in front of it for formatting, and then quotation mark, and in here you write a variable in a curly bracket like this, greeting, and then name dot you have visited, visit underscore Tim for me, time for you, times. Let's see. It's much easier this way. So remember formatting. It applies to us when creating commands. This command doesn't like that. And this you will make typo all the way through the script. So let's keep it that way. So format and use the variable on the curly brackets. All right. Okay, maybe you can change the script that you just created using that into something like this. Okay, let me do that. Open simple function that I created. There's the command that I don't like. Copy that. I can remove this. Put them in the curly brackets. Curly brackets. We don't need that space. Curly brackets. Curly brackets. Close it like this. See, it's much simpler. All right. Do the same here. That becomes input file. And then output file. It's quite simple, much simple, isn't it? Okay, it's much simpler this way using format O, and don't forget putting F in front of it. All right. Okay. Good. Next is working with path. So say we have a Haha project and it has T1, and under the T1 under the subject1 directory, you have subdirectory is called T1, resting state fMRI, and this. And under that, you have T1 nifty and rest and data and bvax and bvals. So location of each file. So location of subject1 is that long. That's your path for the subject1, path for the subject2, and path for the diffusion data within the diffusion is that. And for subject20 is that. Subject20 bvax is that. But if you look at them, loads of strings are repeated, and you don't want to write that all the time. Okay, you can use something else. called path from a pathlib. Let's try using that. So this time I'm going to go to Python again. Save exit, IPython. And I have to import so from pathlib, it's a library called pathlib. From that library, I want to import a function called path. Bear in mind, P is in capitals. Okay. For me, my data is like here. It's very long. So what I do is project_dir is path. I'll make a path. Copy that, paste it, /project_keychart. Okay, it can be different for you. It can be different /data or /phs something, and then your name and example data. Okay, just give a path with a path object, not just a string, but put that into path function. So if you do project_dir, so now it returns saying POSIX path. You can do something like project_dir dot is _dir. Is it dir? Yes, it is. Is it file? No, it's not. Okay, and it's very easy to say in project keychart there, I want to see what's in there. So in that project_dir, I have 3 subjects, but normally you have to write everything. The subject 1 is in there, and then subject 1. But what you do now is simple dir, and you just do slash and give subject 1 here. That's subject_dir. Okay, subject_dir. What is it? It gives the full directory without adding, without making it a string or anything. It just do it for you. And also it does the same, it has the functionality for you. Is it file? Is this for the file? No, it's not. Is it directory? It's not. I'm not sure why it's not. It's probably because the spaces and open parentheses in my Dropbox. I don't know why Partners does that, but it does to mine. Okay, it should say it exists as a dir. Oh no, is the typo there. Subject_dir dot is dir. Yes, it is. Okay, you can do the same thing with diffusion dir. Will be diff_dir is subject_dir. It's under the subject directory, and diff dir is this, and dwi is inside diff dir, and data nii.gz evax diff dir evax. So after setting a few lines like this, you can get files much easier. You will see later in a script why I'm doing this. All right, so try doing something like that. We tried running, is it file? Is it directory? And you can also get the base name of the file. Try .name, try let me try it. So bvax dot name, it just gives the file name only without the path. Bvax parent, it gives you the directory where the file is. And yeah, you can do that. And say project_dir. Project_dir was this. You can get all files using the Linux patterns like meta characters dot this. Then it says generator. If you listerize this using list, then it show you all the subject directories in the project_dir. You'll be using it later. We're not using it today, but just know that there are functions like that. Okay, We tried this. We tried if statement on the first lecture. So we could do if this, do that, not this, do this. So you can mix that with isdir or isFile. So if that file exists, don't run this. If that file don't exist, run that. You can do it something like this. So sometimes you want to extract volume, you want to do something, but you don't want to overwrite, then you should do something, make something like this. So if the output file is file not, so if the output file does not exist as a file, run it. And if not, do nothing. You can make your function like that. Okay, let's make that. Okay, I'll exit from here. And I find my simple function there. I'll open my simple function. I want to make if path, or import it first, import from pathlib, import path, if path output underscore file is file. If it's a file, if there's no file, run this. The same for this. Yeah. So it will only run the extract v0 and that if there's no file exists. All right. Okay. And last thing. Although the titles say extract v0, embed is quite intuitive, at least for us. If I give my function to another people in different lab, they don't know what this is. They will not know what extract to v0 is. They will not know what that is. So you can add an explanation to your function by adding 3 quotation marks. This extracts first 3D volume from a 4D nifty file and saves as nifty. Okay, something like this. And close with 3 quotation marks. You can make it more detail, like you can add key arguments. Key arguments are input file, which is path for the input 4D file, and output file is path for the output 3D file, nifty, something like this. The more detailed your explanation is, better for the other people to understand it. All right, that was the functions. So it was quite a lot. But if you think back, we did making a simple function, adding 1, multiplying 2. Okay, that was easy. And we made a pipeline that runs this and that. We did the same with the Linux commands. Okay, last one is quite extra. You don't have to understand at this point, but I try to explain the class in a easier way that applies to neuroimaging more. So say we have a project called, say we have a project called haha. So we have haha project, and we have data inside /data/pnl/haha project. Okay, then we have subject directories under that, and each subject has consistent structure. T1 nifty in that, RSFMRI and REST file in that, and all the diffusion files on the diff subject tree. And yeah, and same for the second subject, and so on. They are very similar for all the subjects. So I want to make a tool. That takes the subject folder path as an input and register all the path of image files and store it in a single object. Okay, I want to take an input of where the subject folder is, where the subject root folder is, and I want to give that to a tool that I'm going to make, and I want to get a single object with all the information. Again, this single variable that I'm going to create, I'm going to call that subject1, and it will have T1 nifty path, which is in /data/pnl haha project, and then subject1 and T1 and the T1 nifty. as a subject 1.t1. I want to store that information here, .t1, and REST against let's say PNL, haha project, and in there, here. And same goes for DWI and DVEX. Okay? Because they are all consistent, I don't have to type that every time. If I know the structure, and if I keep the structure same for the whole project, I don't have to grab everything every time. I can just grab them. I can just make a tool that knows my rule and create this single object that has all the information. Since we know all the information, just giving the input of the subject root directory, we can register functions to it really easily. And this time we don't even have to give inputs because we know what is the input for the extract p0 and what is the input for the bet. We can just set them in the rules. Okay, that's called object-oriented programming. You don't have to know the words, but let's just try scripting this in Python. Okay, let's go to, so get out of this, or save and get out. Let's go back to IPython. Let's create this class. So it's not a definition anymore, it's a class. So you are making a tool for creating another object. That's called class. And I wanna create a class called subject. And that's just what you have to memorize, just put object there. And definition, underscore twice, and init underscore twice, open, self, and the input here. It might be confusing for you. So init, you're making a function inside the subject directory, and it's just telling you that whenever this subject object is created, run the function here. Okay, and that's the input that you should get. You'll get it as you go along. So self, register something to the object. So code subject dir. I want to register that as subject dir. Okay. Let's just do it like this. And let's make subject 1, which was subject 1 equals subject class that I made. Open, my subject is inside project kcho / subject 1. Now I created an object using a class function that has information of subject dir. Okay, let's do with path. Let's do with path. Let's import from pathlib, import path. Let's make a class again. Class, subject, object, colon, enter, tab, definition, underscore twice in it. Self is just the syntax that you have to follow. And the input that we've given here. Okay, close and colon. Self, subject dir is now pathlized subject dir. And where's my def directory? Diff dir is underscore self inside the subject directory, which was this, and diff, wasn't it? Okay, and self, where's my DWI? Is inside self diff dir, is called inside diff, and called diff.nii.gz. Okay, and my nodiff should be self.diff dir / nodiff. Self nodiff brain, which is the output of the bat image. Diff dir, I wanna create them later, but I'm just setting the path variables here. Okay. Subject 1 equals subject class, and input should be subject dir, which is project kcho and subject 1. This will be different for you because since we saved the example data in different paths. Now subject 1 object has nodiff, has brain, has DWI as well. Yeah, everything registered. This might be confusing in the beginning, but if you keep every variable related with the subject that we're gonna analyze, is much simpler later. So you forgot where the mask is, or at the end of the day, you don't even have to remember where your mask is. You just gotta set it once and then keep the rule. Okay? All right. So let's try adding functions to the object now. Let's try adding functions that we added before. So let's go up again, go arrow up button, and then let's create another definition. But bear in mind, your def got to be in the same column as the def above. Extract b0. I want to make a function that extract b0 self, since we don't have to take any inputs. The command, I'm going to make a command. And format, I want to FSL RY. And as an input for the FSL RY, I want to put in raw diffusion file, DWI, that we set here. So now you don't even have to worry about where your data is. Now you give the variable, and then output, self, no diff. You already set it up here, so you don't even have to worry about it. From the 0, volume 1. Okay? And you wanna, let's print it for now. Okay? We create another function there. So go up again. I want to create subject1 object using the new subject class. Okay? With the extract b0 function. Let's try running that one. Dot extract b0, open parentheses and close it. See? Now I don't even have to worry about where my DWI is. This applies to the second subject, really easy. Second subject, subject 2, run extract b0. Since I'm just printing them, it's not actually running them. But if you put them as os.poppen and command and read, it will run that command. Okay? All right. Where was I? Okay. You can try actually running it by editing that as os.poppen, open bracket, open parenthesis and command, and closing it and read. So class creates an object that stores stuff as well as functions. So it can be structured like this. So now extract b0 and that doesn't take any input. Well, you can make in a way that takes input as well, but doesn't have to at this point. And you can just run it simple like this. So there's a class. At this point, you don't have to understand it, but it comes very handy in making pipelines. Right, another thing, say there was a HaHa project. Say we have new project called Cocoa project. And the structure is very similar to the HaHa project. The Cocoa project has DWI named as data rather than dwi.nifty.gz. One way that you can do this is copy the whole file, whole text file, whole Python script, and then just change self DWI into data, or you can inherit the class. You can reuse the subject that you created. So now you're not getting an object when you create class. Now you're inheriting a subject. By doing so, you have everything that you created in subject also stored for subject Cocoa. You don't have to define that. You don't have to define extract b0. You just gotta put them in here. Then you have everything. And then for initializing function, you initialize the subject first, and then you just update the DWI into data. Then this will run. Another example, say your Cocoa project has b0 volume on the third volume rather than the first volume. You have to change the function, but you can just only change the function without changing anything else. So you just inherit the subject, when creating a new subject Coco class and do nothing, but just create a new function into it, extract B0, and then just update 2 here. This significantly reduces the lines of code that you have to write. This is why class is really powerful. So you don't have to repeat. So there was some class inheritance. So my Kcher pipe is what I use in the lab a lot. Everything is in this way. So I make a template subject directory structure in a Kcher subject, and then I just inherit that in 4 different projects: Sharp project, neuroif project, or other projects. I just inherit them and then edit little and just run them. All right, but today's and all the other sessions with Python having with me are not to make you an engineer. It's to make you better understand the concept of Python and give you a kickstart. You're not going to build your pipeline in class, okay? But in this way, you can understand what class is, what object-oriented programming is, easier in a way. Because if you understand that, there are a bunch of tools related with neuroimaging that's invented by so clever software engineers we don't have to worry about. But without learning class, without knowing what functions are, you won't be able to understand what these are. Smooth dot inputs dot input in files, you don't know what that is. But now you understand, so in a smooth object, there's an input variable in it, but there's a dot represent another object inside, and dot in file. So you have this imaginable structure in your head, okay? And NePipe is a really good example of for making pipeline for neuroimaging. You have to go back and forth between SCPM, FSL, and AFNI, and right, you have to go between them loads of times. But using NePipe, actually merge them together in a Python and in very Pythonic way. So if you're interested, have a look at them. So say for a project, we have many subjects, and you have a bunch of order of functions that you want to apply for all of the subject. You name them like this and get the output for all of the subject. This is done by NePipe workflow. This is just one example, and I'm just showing you how simple it becomes when you are using other tools. Yeah, but before using other tools, it's better to understand what the basic concepts are. And that was a basic concept for pipeline today. And this is the practicals. I have 2 pages of practicals. It's a bit hard, but if you have time, go through them. And I think that might be helpful. Thank you.